Hello everyone, welcome to another video. In this video, we are going to know about acid deposition. Acid deposition is commonly known as acid rain. First, we will see the definition of acid rain. Any form of precipitation with acidic components that fall to the ground from the atmosphere in wet or dry forms is known as acid rain. And the acidic components include sulfuric or nitric acid. Whereas the precipitation can be in any form. This can include rain, snow, fog, hail, or even the dust that is acidic. In simple words, we can say that the precipitation of acidic components is known as acid rain. Normal rainwater has the pH of 5.6, that is slightly acidic. This is due to the presence of carbon dioxide in the atmosphere, because this carbon dioxide get dissolved in the rainwater and forms carbonic acid and makes the rainwater slightly acidic, and which has the pH of about 5.6. The oxides of nitrogen, oxides of sulfur, and volatile organic compounds that are produced during the combustion of coal and petroleum get oxidized in the air to form nitric acid and sulfuric acid. These two acids are the important components of acid rain, and being strong acids, these have the capability to dissolve quickly in the water vapors. As they dissolve in the water vapors, they wash out as acid rain. As discussed earlier, that the normal pH of rainwater is 5.6, but when the pH of rainwater becomes less than 5.6, it is termed as acid rain, or we can say that the acid rain has the pH of rainwater which is less than 5.6. The pH of rainwater is further lowered as 2.4. Next, we will see the major sources of sulfur dioxide and oxides of nitrogen in the atmosphere. These are: first is burning of fossil fuels, second is vehicles and heavy equipments, third is manufacturing, oil refineries and other industries. One important point to remember is that winds can blow oxides of sulfur and oxides of nitrogen over long distances and across borders also, making acid rain a problem for everyone, not just for those who live close to these sources. From this diagram, we will understand the acid way pathway. First, the oxides of nitrogen and oxides of sulfur are released into the air from industries, automobiles, vehicles, and from here these particles and transported to long distances and are transformed into the acidic particles. These acidic particles then fall down to the earth in the form of dry deposition or wet deposition, and on the earth these causes harmful effect on soil, streams, lakes and forest. Next, we will know the reactions that are involved in the formation of sulfuric acid and nitric acid. When sulfur dioxide combines with oxygen, it forms sulfur trioxide. And this sulfur trioxide, when combines with water, then sulfuric acid is formed. The nitrogen monoxide combines with oxygen to form nitrogen dioxide, and when this nitrogen dioxide again combines with water, then the formation of nitric acid and nitrous acid takes place. Now we will see the types of acid rain or acid deposition. Acid rain is of two types. First is wet deposition, a second is dry deposition. Wet deposition occurs if the acidic chemicals in the air are blown into the areas where the weather is wet. The acidic components can fall to the ground in the form of rain, snow, fog, or mist. As this acidic water flows over and through the ground, it can affect a variety of plants and animals. Next, that is dry deposition. Dry deposition occurs in areas where the weather is dry, and these acidic chemicals may become incorporated with dust or smoke and fall to the ground through dry deposition by sticking to the ground, buildings, vegetations, cars, etc. The dry deposited gas particles can be washed from these surfaces by rainstorms through runoff. This runoff water makes the resulting mixture more acidic. One important point to remember is that about half of the acidity in the atmosphere falls back to the earth through dry deposition. Now we will see the effect of acid deposition or acid rain. First is the effect caused on humans. In humans, it reduces visibility, causes irritation of the skin, eyes, and respiratory tract. Some other direct effects include chronic bronchitis, pulmonary emphysema, and cancer. Second is the effect caused on soil. In soil, it results in the leaching of soil nutrients. Essential elements like calcium and magnesium are leached easily from the acidic soil that are resulted due to acid rain. There is also increase in ammonia in the soil due to decrease in other nutrients, which results in the decrease of the rate of decomposition. The nitrate level of the soil is also found to be decreased. One important point to note is that the impact of acid rain on soil in India is less because Indian soils are mostly alkaline, having good buffering ability. The buffering ability or the buffering capacity of soil depends on the base saturation. That is the amount of positively charged cations in soil. The higher the base saturation, the more buffering capacity of the soil will be. And this results in the neutralization of the acidity of acid rainwater, which is called buffering capacity or buffering ability. Third is the effect on aquatic life. It results in the death of aquatic animals. Fourth is the effect on terrestrial life. Acid rain damages cuticle of plant leaves and reduces photosynthesis. Acidic medium promotes leaching of heavy metals like aluminium, lead, and mercury. Such metals, when percolate into groundwater, they affect soil micro, flora, and fauna. Fifth is the effect on buildings, monuments, and materials. Many old historical Asian buildings and works of art and textile are adversely affected by acid rain. Limestone and marble are destroyed by acid rain. Many buildings, such as Taj Mahal in Agra, have suffered from the acid rain, which is known as marble cancer. At last, we will see what are the acid rain areas. They are concentrated in the industrialized belt of the northern hemisphere. Canada, the northeast United States, and northern western Europe are included in acid rain areas. In India, the first report of acid rain came from Bombay in 1974. Lowering of soil pH is reported from northeastern India, coastal Karnataka and Kerala, parts of Orissa, West Bengal, and Bihar. At last, we will see how to control acid rain. First is the use of low sulfur fuel or natural gas in thermal plants that can reduce the incidences of acid rain. Second is buffering, the practice of adding a neutralizing agent to the acidified water to increase the pH. This would usually be in the form of calcium oxide and calcium carbonate, that is lime. Here we can note that the nitric acid, that is HNO3, does not affect on marble, and cases of acid rain are less in India as sand in Rajasthan is very rich in calcium and the wind neutralizes the acidity. That's all for today. Hope you liked it. Thanks for watching.